Yeah, as we mentioned during our tech check, if you weren't here, I'm here with Maury Creighton from Pinpoint Laser Systems. Maury, welcome to the show. And what are we looking at here?
Well, great, Dirk. It's fun to be here today. This is our Microgage 2D laser alignment system, and Pinpoint Laser Systems for about the last 20 years has been building these systems to help industry and manufacturing companies basically check their manufacturing processes, improve the efficiency of those manufacturing processes, and ultimately to turn out better product through those processes. So
describe the pieces that we see here in front of us.
Sure. This is a fairly typical system, and it really is comprised of three components: a laser transmitter, a digital receiver, and a display unit. And I'll just talk about the laser to begin with. Our laser is basically machined from a solid block of material. It's aluminum. Sides are square and machined flat, and you'll notice there are all sorts of mounting holes around this product, so it can be attached to fixtures or tripods and things like that.
And this is eye-safe laser?
It is. Okay. It's a low-power visible laser. It runs on 4 AA batteries for about 20 hours on a single set of batteries. There is a precision bubble level up here in the top. It's accurate to 10 arc seconds, and in fact the user can take the cover off and adjust it if they decide to do that. And when you turn the laser on, there is a laser beam that comes out the end, and this beam is parallel to the base of the product and also to the sides. So if we set this down on the surface here, this beam can be used out to about 200 feet away. The receiver is similar in design. It's machined from a solid block of material. It's flat and square with, again, mounting holes. And you'll notice in the end here there is a port, and the laser enters this little port, and it can measure with a detector behind where that laser beam is left and right and up and down. So the laser beam goes into this receiver, and then the receiver is in turn connected to a display unit. In this display unit you can change the units of the measure from inches, you can save readings and things like that, but it's basically telling you here where that receiver is in a vertical orientation and in a horizontal orientation relative to the laser beam. So if they're both sitting on the same surface, you can see that the vertical reading is reading very near to 0. And if I put just a card underneath this receiver,
this is just a business card.
It elevates it up, and now we can see that that reading has changed.
By about a thousandths, was that it? Okay.
It's showing about 13 thousandths there.
Okay.
And the beauty of the system is that you can make these measurements where this receiver is right up close to the laser, or it can be moved up to about 100 feet away. And depending on customers' applications, we have customers doing all sorts of different things. Well, for example, in the semiconductor industry, they're lining up robotics and transport systems and stages. So they might be working typically in a 1-meter envelope. In the medical world, like MRI scanners and PET scanners and things like that, they're lining up the patient table and the rings that pick up the measurements off of the patient. And so that's a larger envelope, and then we get up to the aircraft and helicopter business, which we do a lot of work in. Our customers buy these systems. They're lining up wing fixtures, landing gear, propeller shafts and ships, all sorts of industry.
How would they have done this in the past, with not using a laser system? What would have been the old way of doing this?
That's a great question. Typically, customers in the past have used piano wire, fishing cord. They've pulled it between machines.
And then they just measure between the wire and their surface to get offsets and so forth?
Exactly.
Okay.
With a ruler, it's effective, but fairly, you get 3 or 4 people making that measurement, you're going to get different answers. And of course,
time-consuming too as well.
Time-consuming and
wire sags,
string sags.
Yeah.
The beauty of using a laser beam is that we're basically just replacing that string with a beam of light and allowing customers to quantitatively measure what that machine is doing, so they can then store that information and act on it a little more accurately.
Okay, I notice you've got a few other little options that go with this.
We do. This particular attachment right here is called our 90 line, and what it is it's got an optical pentaprism in here, and when I place this into the laser path, there's a beam that comes up that is vertical, and this beam can be actually adjusted. As I turn this piece, the beam can be deflected around through a plane that's square to the original laser line. So this becomes very handy when you take this receiver and want to check the squareness of machinery. It can be used for checking planar surfaces. And one other advantage is, once you set this up, if you move this 90 line to different locations, you can create a series of parallel lines. So now that you can use that for checking assemblies and gantries and slides and rails and anything you want to check to make sure it's parallel.
Is that 90 degrees here dependent on how straight this is?
Good question. Actually, there's a pentaprism in here, so the beam does not change. The 90-degree relationship between the ingoing beam and the outgoing beam remains the same.
Okay.
Even if that's moved.
Oh, interesting.
Exactly.
Okay. So you're always going to get even if this is off a little bit, you're always going to get exactly a 90 degree from the incoming beam.
Exactly.
Okay.
I mean, a typical example is in paper mills and applications like that. They'll set the laser up in the aisleway and they'll shoot the beam 80 or 100 feet down the aisle, and then they'll place this down at the distance to redirect the beam in to check rollers to see if those rollers are parallel.
Okay.
And that becomes important because if the material stretches over those rollers, it ultimately creates product that's not as useful as product that's lined up on straight rollers and is really flat and symmetric across
Sure,
the
and it's
surface.
really important to get rollers, particularly on web processes. Those things got to be aligned just right on the money.
They do.
Okay.
They really do. Another accessory we have here is a cylindrical laser, and we build a variety of different lasers for customers and also a variety of different receivers to fit into small places and do things. This laser is round in nature. It, again, runs on 4 AAA batteries for about 10 hours. When we turn it on, there's a laser beam that comes out, and this beam is aligned to be parallel and centered on this mounting chuck on the back. So this can be attached into a lathe or a spindle or injection molding machines, things like that, where you want to basically check this symmetrical nature of the machine. So if you're looking at the laser and the receiver together, this will not only tell you where that alignment is up and down, left and right, basically what we call sort of the run out, but it also tells you about parallelism. You know, are these machines parallel to each other? So
I would imagine also it could tell you whether the chuck is true perpendicularly, because you would see a wobble as it turned, right? If you were to rotate it through 360 degrees and it wasn't perfectly perpendicular to the chuck, you would expect to see.
That's exactly right.
Okay.
That's exactly right. When you turn the chuck or whatever's holding this laser 180 degrees, half a turn, what you actually do is you sort of double all the errors that are in the chuck and the mounting.
Right.
So, and when you're measuring it with a receiver that can measure down to a 10,000th of an inch, you can see everything.
Okay, now I noticed on the back of this, we've been talking about one receiver, but it looks like I see on the back we've got several inputs. You can bring multiple receivers into this?
That's correct, yes. The back of this device has 4 input ports, and that basically allows you to have multiple receivers. And for example, we have a transparent receiver that can be placed into the beam path, and you can make multiple measurements along a single line.
And the beam just passes through it?
Passes cleanly through, and it takes a sample measurement at each location.
Okay. And we're starting to run out of time here, but also I believe you said you can tie this via USB into a computer for what reason?
Exactly, yes. There's a USB port, and we have a simple program called Pinpoint Capture that runs on laptops and PCs. It allows you to see a number of readings simultaneously if you have multiple detectors. It allows you to store those readings. It saves those readings in an Excel format so that you can then upload them into spreadsheets or statistical programs or whatever you're doing.
Okay. So. And basic cost, kind of the base price for, let's say, what we're seeing right here, minus these options, but what do you got, the laser, the receiver, and the controller here?
Sure, yeah. This is sort of the core of the system, and there are accessories that can be added, but the typical cost begins at around $14,000. And by the time you have a lot of different accessories, you might be sort of $22,000. We also customize these as people need them to, and so we'll make fixtures or provide customers with drawings so they can make fixtures and attach them to their machines.
Okay. Well, this has been Maury Creighton from Pinpoint Laser Systems, and this was the Microgage laser...
A Microgage 2D laser alignment system.
2D laser system.